I am Praveen Raj and my seminar topic is about dynamic scattering type, field effect type, advantages and disadvantages of LCD. Based on construction, LCDs are classified into two types, dynamic scattering type and field effect type. Construction of dynamic scattering type liquid crystal cell. The display consists of two glass plates, each coated with tin oxide or indium oxide. Inside, there are two transparent electrodes separated by a liquid crystal layer of size 5 to 50 micrometer thick. The oxide coating on front sheet is etched to produce single or multi-segment pattern of characters, with each segment properly insulated from each other. A weak electric field applied to a liquid crystal tends to align molecules in the direction of the field. As soon as the voltage exceeds a certain threshold value, the domain structure collapses and the appearance is changed. As the voltage grows further, the flow becomes turbulent and the substance turns optically inhomogeneous. In this disordered state, the liquid crystal scatters light. When the liquid is not activated, it is transparent. When the liquid is activated, the molecular turbulence causes light to be scattered in all directions and the cell appears to be bright. This phenomena is called as dynamic scattering. Field effect type. The construction of field effect LCD display is similar to that of dynamic scattering type, with the exception that two thin polarizing optical filters are placed at inside of each glass sheet. The LCD material is of twisted nematic type which twists the light, that is, change in direction of polarization, passing through the cell when the latter is not energized. This allows light to pass through the optical filters and the cell appears bright. When the cell is not energized, no twisting of light takes place and the cell appears dull. In this, polarizing filter works by only allowing light in a certain pattern or orientation to pass through. For better understanding, consider this as a light wave. There are two types of polarizers, vertical polarizer and horizontal polarizer. Consider a vertical polarizer. When light waves are passed through, it allows only the vertical light wave to pass through and blocks the horizontal light wave. This is a liquid crystal. When it is connected to an external electric field, molecules align towards the field. When it exceeds threshold value, the molecule structure changes. When a light wave is passed through a field effect type of two thin polarizing optical filters are placed. The LCD material is of twisted nematic type which twists the light passing through the cell. This allows light to pass through the optical filters and the cell appears bright. Then it is allowed to pass through a color filter to change its color. Basically, three primary colors, that is red, green and blue color filters are used. The combination of all three colors produce white light. Based on the color which we needed, the intensities of any color may be changed and the required output color may be obtained. The combination of these three cells are called as one pixel. By using multiples of pixels, one image can be produced. Types of liquid crystal cell. There are two types of liquid crystal cell: transmittive type cell and reflective type cell. We can see about that. Even though operations is quite similar, there is a major difference in their constructive property. Molecules in liquid crystal material in absence of an external field. It remains transparent and it does not scatter light, so the cell remains dull. When an external electric field is applied, the molecules tends to align in a direction of an electric field, and then when it overcomes threshold value, the molecules starts to change its alignment and cause a turbulence. This causes scattering of light and makes the cell look brighter. Side view of liquid crystal cell. Outer part is of glass, and in the transparent electrodes are placed, insulating themselves using liquid crystal material. In a transmittive type cell, both electrodes are of transparent material, but in a reflective type cell, one is of transparent electrode and other is of mirror surface. Next, consider a edge view of 7-segment transmittive LCD. When it is not activated, cell appears transparent. When activated, cell appears quite brighter. It appears brighter even under bright ambient conditions. Next, a reflective type cell. It is operated with external light source. When not activated, the mirror surface reflects and causes the cell to appear transparent. When activated, dynamic scattering phenomena occurs. However, the major difference between reflective and transmittive is that reflective uses external light source and transmittive uses internal source. Liquid crystal consume small amount of energy. In a 7-segment display, the current drawn is 25 microampere for dynamic type and 300 microampere for field effect type. LCD requires AC voltage supply. Typical voltage supply is 30 volt with 50 Hz frequency. LCDs are normally used for 7-segmental display. Advantages of LCD. Voltage required is very low. They have a low power consumption. A 7-segment display requires about 140 watt, that is 20 volt per segment, whereas LEDs require about 40 milliwatt per numeral. They are economical. Disadvantages of LCD. LCDs are very slow device. The turn off and turn on times are quite larger. Turn on is of order of few milliseconds, whereas turn off time is 10 milliseconds. When used on DC, their lifespan is quite small. Therefore, they are used with AC supplies having a frequency less than 50 Hz. They occupy a large area. Thank you.